A small object is hung from a bar using a string, and when it's at equilibrium it will be at position C, but if it is taken to position, let's say position B, and then released, then it will be like a simple pendulum. It will go in this direction and then come back, and slowly it will, afterwards it will cease to move and it will come back to this position, which is position C. Now what happens is, here it can be taken at B prime as well, in any direction, and it works as a simple pendulum. So when it is at position B and it is held there, it gains a potential energy, and when it's released the potential energy is converted into kinetic energy, and that's why it keeps moving in this direction. And at point C, at position C, let's say at position C, it will have the potential energy will become zero, and the kinetic energy will be maximum. The most of the all of the potential energy will be converted to kinetic energy, so it will have the maximum velocity at C. Now if it is taken further up before it's being released, then the amount of potential energy will be even more. And at position A, which is just perpendicular with the vertical position, that is position C, then it has the maximum potential energy. So when it's at position B, the effective height is h here, and that is this much. Let's say the length of the string is L, uppercase L, and height is h when it's at position B. When it's at position A, that's the maximum scenario, this one is, the height is L, the length of the string, because this is the length, this one is the length, and this is exactly the full length basically. Now at position B, if we say it makes an angle theta with the vertical position, that is position C, then when it's at position A, the angle with the vertical position becomes 90 degree, this one, and that's the position there. So if we want to calculate the height h in terms of any variable theta, what we can do is just look at this height h. So if we look at this much length, this one will be, since this is L, when position B, the string length is always L, so this much is L. Let me use another color. So this is L here, and this angle is theta. So this length is L cos theta, because cos theta is equal to this one over L, which is, let's say this is x, this much if we call it x, so x is L cos theta. Now according to the variation of cos theta, this height, which is this height, this is this much, this will change, and when it's at position A, this becomes 0, this much becomes 0. So our height h is basically L minus L cos theta. If we look at here, this one is full L and this is L cos theta, so this height is L minus L cos theta. So that's the height which is a function of theta. According to the position of theta, this becomes, the height changes basically. So when it's at position, let's say at position C, theta is 0 because it's aligned with the vertical line. So of course height is 0 because it doesn't have any potential energy. So if we recall, potential energy is mgh, and of course at this position there is no potential energy. Now if it moves to position A, which is the case of maximum potential energy, which it should be, and we can see in our equation theta is 90 degrees, so L cos theta is 0, so H is L. So that's the maximum possible potential energy when it's at position A. Now depending on position of theta, depending on the value of theta, the potential energy will vary, and according to the variation of potential energy, the kinetic energy will also vary. So this velocity will be more when it is actually released from a higher position, or let's say from a higher angle. When it's released from a higher angle, the velocity will be more, and as expected, because potential energy is more. And at position C, the velocity will be maximum, because potential energy is zero and kinetic energy is maximum at that position. That is changing only because of velocity. So that's there. Now if we want to do an example problem, the problem says that the length of the string is 1.2 meter. A small object of mass 0.6 kilogram, which is hung from a bar, and the angle it makes with vertical position is 20 degree, and its length is 1.2 meters, and the the mass is 0.6 kilogram. So this is the information. We need to find what is its maximum velocity when it's moved. So that is at this position, when the kinetic potential energy changes into kinetic energy fully. So the potential energy when it's at this position, that is the angle is theta, the potential energy is mg, and then if we say this is h, we can just directly write L 1 minus cos theta. So this could be written as h can be written as L 1 minus cos theta, because L minus L cos theta, so this one. So this is the potential energy, and kinetic energy, when it's the potential energy is fully converted to kinetic energy, that is given by half mv square. So that is at this position, and that's the maximum velocity basically, and that's what we want to find. So half mv square is equal to mgl 1 minus cos theta. So we actually don't need m. V square is 2gl 1 minus cos theta. So V is square root of 2 times 2gl 1 minus cos theta. So G is 9.8 meter per second square, L is 1.2, and theta is 20 degree. So if we plug in the values, we get V as 1.19 meter per second. So that's the velocity, the maximum velocity. So I will write down the problem in the description section. State the problem in the description, video description basically.